So let's revise what we have went through in our last session. Hello, hello, hello. Okay. Screen sharing. Okay. Hmm. Yes, you can give the attendance in chat box, and so we will revise what we went through in our last session. So we went through the basic of the digital image processing. So in that we went through what is meant by digital images, what is meant by pixels, what is the history of digital image processing, when it started, how it has evolved, and what is the present scenario of digital image processing. Also, we went through different applications where digital image processing has been adopted, and it actually serving as a uh, edge in different fields. Like in medical image, it is digital image processing, which enables doctors to actually identify the problem or the disease in the patients and try to cure it. And similarly, in space program, the images are easily being uh, enhanced, and that is very useful to the researchers or scientists who are working on space. So, so this was what we went through in our last session. So today we will go with the very important part of digital image processing, that is the key stages in digital image processing. So we will look into what are the stages involved when we have a digital image processing system. So in general, the digital image processing system has this many stages. So it starts with the image acquisition, then image enhancement is done, then image restoration is done, morphological processing, then segmentation, then object recognition, and finally representation and description is done. So apart from that, two other stages are there, which are image compression and color image processing. Now, image compression and color image processing are kept separate, not in this cycle. It is because the image compression and color image processing applications are completely different. For example, image compression is used to store the image and also to transfer the image so that the bandwidth, optimized use of bandwidth can be done. And color image processing is related with color images. This mostly what we do is we don't process color image, we process uh, grayscale image or black and white image. The reason for that is when we talk about color image, their size is almost like 3 times the size of grayscale image. So if you consider that, then the processing requirement or the memory or this the MOU, this microprocessor capabilities for processing those color image requires are very high. So that's why mostly we do is grayscale image processing, not color image processing, but some application may require color image processing. So at that time we adopt color image processing. Okay. So let's look into one stage by one stage. So first stage is image acquisition. So image acquisition is capturing the image, capturing the actual scene in a form of a image, right? that is 2D, two-dimensional. If we talk about grayscale, it will be two-dimensional image. Even color images are also two-dimensional image. They are not three-dimensional, because when we talk about images, then only we capture is 2D, not 3D. Okay. So to capture an image, what we require? The first thing, of course, we require camera, but more than the camera, we require some illumination source. Illumination source means some energy source we require. In general, we have sun as our energy source or illuminating source, or sometimes we have artificial bulbs for giving the light, right? And that is very important, and it is not always the sun or a bulb. So it depends on this image acquisition, depends on the source you are also adapting. For example, in an x-ray machine, you actually acquire the image in a form of x-ray images, right? So there the source should be the source which should be able to generate x-rays, and that x-rays will become the source. For ultrasonic images, the source is ultrasonic sound, right? So image acquisition device like camera or ultrasonic or X-ray or CT scan, these devices uses different source to capture the images. So always there should be some source, and there should be some scenic to which we are going to capture, and then we capture the image and store it, right? Then the second stage is the image enhancement. So always what is captured might not be up to the mark, or might not be visually clear to us. So what we need to do is we need to enhance the image. There are different techniques by which we can enhance the image, and we are going to go through these techniques one by one. But the after acquisition, the next step is always enhancement. So once enhancement is done, then we can go for other steps. The other step is image restoration. So in image restoration, after enhancing the image, if there are some noise in the image which we don't want, then that has to be removed, and then we need to restore the image so that the noise are cleared from the image and we get a clear image. So that's why after enhancement we go for image restoration. So once the image restoration is done, so here is an example here. So after enhancement, the image looks like this. So it has been processed through a restoration technique, and with that restoration technique, image now it's more clear than previous. And this clear image, we can actually identify what are different things in the image. But in this, it is very difficult to identify. So this restoration process has to be done. So once restoration process is done, we go for morphological process. Now morphological process are different techniques using which we can actually identify the features in an image. For example, here example is given is the biometric fingerprint image processing. Okay. So these are called biometric image processing because these images are of biometric. Let it be fingerprint or even our what we call as retina scan. So retina scan or eye scan comes under biometric, and there are different others also, like face detection also comes into biometric. All those comes under biometric. So we require morphological operation. Of course, in this subject, we will also go through morphological operation. So here there is an example of morphological operation. So once the image is scanned, so you can see here there are extra dots which are not required. In between these fingerprints also there are dots which are captured by the fingerprint scanner, but we don't require this. So we adopt some morphological process so that those dots vanishes, and another morphological process so that the lines, fingerprints, which we require is enhanced. Only the fingerprints get enhanced, nothing else. Okay. So here the fingerprint are darker, here it became brighter. So once fingerprint are brighter, then we can actually use different techniques to actually, if there are any discontinue. If you can see here, there is discontinuity, right? uh, this is only one line in a fingerprint, okay, but in this one line there are discontinuity due to something on our fingers. This discontinuity arises. So to remove this discontinuity, another morphological operation is applied so that we get a continuous continuity. And then because of this the width of the finger line is also increased. So again, that width is decreased to the original, and we get some continuity and discontinuity, as well as the clear finger lines, right? Once we get clear finger lines, then we can do different other things to actually identify the person from the fingerprint. So these morphological operations are used for this uh, purpose. So you adopt it to increase the weight, to decrease the weight, to fill the holes, to uh, make holes larger, or to fill or to remove the noise, some noise like this one, okay, not the previous one which I have shown. This noise is different from the that noise, okay. So this noise, to remove that noise, so all this morphological operation is adopted. So we will also look into what are different morphological operations. So here you can see there is some mathematical equations involved. Here also you have mathematical equations. So these are actually morphological operations, and we will look into detail of these morphological operations when we come in that part of the our syllabus. Then comes the segmentation. So segmentation is a process where you segment different things in an image. Okay. So here you can see there are two uh, components in the image. So you can actually separate out these two components, and then after separating of these two components, you can then go for other purpose, further processing. So in this actually, so in an image, if you want to identify an object, so first you need to segment those object, okay. So once you get segmented that object, you can look into the properties of that object, and then you can identify what object it is. For example, now let's see the image. This my camera. I am being shown in the image, right? So first, if someone wants to identify who is in this image, then first the person face has to be segmented. So to segment person face, what we adopt, we see where the eyes are, where the ears are, and based on that particular things, that particular part of the image will be segmented. Segmented means we are only considering only a particular part of the image where the object is. It can also be called as region of interest, ROI. So for face recognition thing, the ROI is this box where my face is. So ROI is not entire image, only the region where the object resides. Okay. So in segmentation, what we do is we actually segment the ROI region from the image. So once ROI region is segmented, then we can go for different techniques to identify the object. So here the face is segmented, then we can go with the techniques like the distance between the eyes, the length of the nose, the length of the lips, the distance between ears, and the height of the face, the width of the face. All these features we can take out, and then based on that features we can say that this is particular person in the image. So that way the person is identified. So in these features we are not considering a beard or hair or mustache or any other thing. That's why it doesn't matter whether you increase the beard size or whether you remove it. So present the face recognition techniques are that much advanced. So in that, this particular techniques are used. So this particular features, that is the distance between the ears, the length of the eyes, the distance between the eyes, the length of the nose, and all those things. Okay. So once we get that feature, the object is recognized, that is object is identified, and the name is given to it accordingly. And then last thing is representation and description. So once the object is recognized, you need to tell it, you need to show it on the image. So how you are going to show it? You might have seen that when you are taking an picture, or when you post a picture on a Facebook, then automatically annotation happens that you get this box around your face, and your name automatically gets labeled with that box. So that is nothing but representation and description. Representation is box, and description is given by the label, your name. Okay, so that's how representation and description is done. So once the object is recognized, the representation and description has to be done. So once representation and description is done, that is it. So I have took an example of face recognition. It is not just face recognition. These key stages are not just for face detection. You can adopt it for any. For example, fingerprint biometric. So once you capture, so in fingerprint biometric, you acquire the image using scanner, fingerprint scanner. So once fingerprint scanner acquires the image, that image will be enhanced and then restored, and different morphological operations are adopted, and then the segmentation is done. So only where the fingerprints are there, only that part will be taken, all other part will be removed. Then from fingerprint, what we try to do is we take out the different features. Like if you clearly see fingerprint of any person, then what we have is the starting of the finger line, the end of the finger line, there will be some division in the finger. So some finger line will be dividing into two branches. So where that division is, and how many finger lines are being divided, and again at the center the circle, that circle also ends differently for different people. So all these are features of this fingerprint. So we extract those features, then we recognize the object, that is the person, and then we label the person, we label the object, that is representation and description. Okay. Or in any medical image processing also, the same method is being followed. So for example, in X-ray image, the image acquisition is done using the X-ray. Once the X-ray is taken, that image is actually enhanced, restored, to remove the different components which we don't want, and then morphological operations might be adopted, and then the segmentation can be done based on which part of the body you want. Okay, from X-ray you may be looking for fractured bone, so only bone part will be kept and other parts will be left out. Okay, or removed. That is called as segmentation. Then here you are trying to recognize the fracture. So object recognition will look for the discontinuity in the bone structure, and based on that discontinuity, it might tell the fracture and also the type of fracture. So in medical science, we are not familiar, but little bit we know there might be a multiple fracture. Multiple fracture is a fracture where bone is crushed completely into small pieces, or there might be a hairline fracture. Hairline fracture is a very small fracture, and there might be a breakage in the bone. So this different type of fractures also can be identified. Okay. So mostly all the applications of digital image processing goes through this key stages, and in our syllabus we are going to go through these stages. I mean, the techniques used for different stages. What are the techniques used for image enhancement? What are the techniques used for image restoration? What are different morphological operators, and which operator is used for what purpose? That we will go through. Then how segmentation is done, how object recognition, that is feature extraction, and all those things are done. Okay. So in our syllabus, we will actually go through these stages. Then, of course, there is image compression. Image compression is to store the image. We need to use less. We require small size. We need to decrease the size so that the image can be stored. So if you look into the image compression, there are different compression techniques. Each compression technique is based on the different file format. Okay, file format like I think you might heard about PNG, you might heard about JPEG, you might have heard about GIF. So all these are image formats. In this file format, we store the image. So these file formats are came up with the technique of compression they are using. Okay. We also will go through the different techniques of compressions, and we will try to see that which technique uses which compression. So here in this example, if you are able to see it clearly, then you can see that this particular blackboard image is compressed with a 1% ratio, and size is 12,542 bytes. Okay. Same way, error.png next file is of size 282 bytes, and it is compressed 13%, and so on. So this we can see how much the file is compressed, and what is the size of the file presently. So when we compress a file, again, to view that file, we need to decompress it, right? Directly you cannot view the file without decompressing it. You compress it, then you decompress it to view the file. That's why the file format are important. If you have used the compression technique which is used in PNG, then while opening that file, while viewing that image, you need same technique, reverse of the same technique, to decompress it. Okay. Otherwise the decompression will not be good, and it might not show image, the quality of image might be compromised, or something others might have, which we call as artifacts. So the things which are not present in original image might appear in the image, that is called as artifacts. So we don't want artifact also. So decompression and compression are actually the pair technique. Same decompression, same compression, and same decompression technique has to be used. Otherwise, image quality or artifacts might appear. And there is, of course, color image processing. Color image processing is different from grayscale image processing. Why it is different? Because here you need to take in account the color also. So we have extra dimension which is called as color. So if I want to give an idea how color image is and how grayscale image is, so if we talk about grayscale image, then grayscale image is nothing but it's just a single 2D plane image. But color image, hello, any doubts? Hello. Okay. So color image is nothing but it's a three plane image. So first plane is of red color, second plane green color, and third plane blue color. So when we combine these three color, intensity of these three color, we get all different colors. This is basic color science which we learned in our elementary school. So while coloring, we mix up two colors to form a third color. So same technique is adopted. Here we adopt three colors, that is red, green, and blue. That's why we call it as color image, sometimes as RGB image. RGB is nothing but red, green, blue image. So we have three images. One image shows only red color, that is the red color component in the image. Second image shows only green color component in the image, and third image shows only blue color component in it. When we combine these three together, then we get different color images. Okay. So that's why I said you that the color image requires three times more size or three times more space than grayscale image. So it will require three times more processing, three times more speed. Everything is three times more. Okay. So we are actually in a color image, you are actually processing three images together, not just one image, three images together. That's why processing color image requires much more resources than our grayscale image. Of course, whatever technique we use for grayscale image, same technique we use for color image, only it is we are using for three different planes. Okay, that only the difference we get when we use grayscale image and color image. So whatever we are going to study in uh, grayscale image, that is whatever techniques we are going to adopt in grayscale image, same techniques we can adopt in color image to get the same type of results. Only the thing is you need to do it three times. Okay. So that is it. Any doubts? So these are the key components of our digital image processing. Any doubts? I would appreciate if you have any doubts. I hope you have understood this all stages. We have not went in detail of this because see, image acquisition, you might have an idea of image acquisition like you are using the cameras. Nowadays cameras are very basic things, and you use it in day-to-day life because it's a part of our smartphone. And due to the lockdown also, and due to the COVID, we are in social distancing, and we are using this online apps. So this also uses the camera. So it's very common thing now, camera. So one of the common image acquisition tool is nothing but the camera. Apart from camera, there are many different image acquisition tool. So in our last session also, I told you that don't limit your thinking to camera itself or to visual light itself. Visible light and camera is just one modality of the uh, image acquisition. There are many modalities. You have ultrasonic, you have X-ray, you have the CT scan, you have what we call it as different gamma rays and infrared for night vision, infrared, and there are many different things, right? So all these imaging modalities are available in the world, and these image modalities are to capture the image for different scenario. And then after capturing the image, this enhancement, restoration, morphological processing, segmentation, object recognition, and representation is done. Okay. So same thing is done in color images, only you have to do it three times. So it requires a lot of processing. So you are doing three times processing. So just imagine how many calculations you require. Let's say that you are adding two images. Okay. And let's say you are adding two images. So images are always given in terms of resolution. Resolution means resolution comes in time like 100 by 100 resolution image. That is the size, right? We say width 100 and height 100. So what is that 100 by 100? It is nothing but 100 pixels by 100 pixels. Okay. So in total, how many pixels are there? 100 multiplied by 100. So total it has 10,000 pixels, right? So if a 100 by 100 image is there, then total 10,000 pixels are there. And if you want to add two images, I'm talking about adding two images which are of size 100 by 100. That means 10,000 pixels are added by 10,000 pixels. So 10,000 additions has to be performed. So for just simple one addition of image is nothing but 10,000 addition for a size of 100 by 100. Now if we talk about our phone cameras, so these phone cameras nowadays comes around like 2 megapixel camera or 4 megapixel, sometimes even 32 megapixel camera. So 2 megapixel camera is nothing but there are 2 megapixel, 2 into 10 power 6 pixels. So addition of two such images is nothing but addition operation executed 2 mega times, 2 into 10 power 6 times addition we are performing. So in color image, this is again 3 times of that. So it is 6 mega operations we are performing. So 3 times more operations we are performing in a color image. That's why color image requires more processing than normal grayscale image. There is one question here. Which technology is used to capture pictures in space? So pictures in space generally is a gamma rays capturing device. Most of the universe gamma rays are being transmitted. So gamma rays capturing is generally done in this space. Apart from gamma rays, there are other rays also. What we call this solar energy burst, we call it. Those rays are not gamma, but they are extreme rays. I am not able to recollect the name of that rays, but it is formed due to the solar burst, solar radiation, due to the solar radiation. There is another, that is data annotation. Annotation. Annotation is a part of image processing. Data annotation is different. If you are doing data annotation on image, then it is a part of image processing. Data annotation is nothing but annotation. Annotate is nothing but you are labeling something. Okay, you are giving a label to a particular data. That is not nothing but data annotation. So if you are doing that on an image, okay. So for example, if you are labeling this my a box and you are labeling it as a face, then that is the annotation. That means you are giving it a label that this particular part of image is face. So that is what is label. And when you give a label, that is nothing, that is called as annotation. So if you are doing annotation on an image, then it is of course the part of image processing. But data annotation, you can even do the labeling for data. For example, if there is a uh, uh, some paragraph written, and in that paragraph you are taking out one line and you are saying that this line is for this particular purpose. So you are labeling that line, and because you are labeling a content, that means that content cannot be in image processing because it is a content. So data annotation is giving the label, and if it is done in image, then we call it, then it is a part of image processing. Okay. So any other questions? I hope everyone has understood today's session. Okay, then we'll stop here for today. And okay, we'll stop here for today. And please give the feedback if you think I am running too fast or is complete English is not that much what we say is resourceful. So we can the part which you didn't understood in English that we can go with through Hindi also. So if you are unable to understand that, okay, okay then thank you. Now everyone can leave.